Hello everyone. Today I am presenting my capstone project 6 that is on Netflix movie and TV show clustering. So it is type of the unsupervised clustering. And so what are we doing in this is that study the first problem statement. So problem statement is Netflix is the world's largest online streaming service provider with over 220 million subscribers. And so it is crucial they effectively cluster the shows that are posted on their platform in order to enhance the user experience, thereby preventing subscriber churn. So what is the our goal basically in this project is it is to classify the Netflix shows into certain clusters such that the shows within the clusters are similar to each other and the shows in the different clusters are dissimilar to each other. So first we'll do is we will import all the libraries and a data set. So first we will mount the drive. Then after that we will import the libraries. So first we are importing Pandas, NumPy, Matplotlib, Seaborn for the data manipulation and visualization. Now for creating the word cloud, we'll import the word cloud library and then we will import NLTK package. So it is for basically for the natural language processing. Now to create the clusters and for the cluster implementation, we will import k-means from the SQL under cluster package. Now to create the building recommendation system, we will import the libraries. Now we will load our data set. So we will load the data set. Then we will check the first 5 rows and the last 5 rows using the head function and the tail function. After that, we will see the size of the data set basically means the number of rows and the columns. So here we can see the rows is 7, 7, 8, 7 and the columns is 12. Now we will see what are the unique values. So these are the unique values. And you will see using the unique function. Now we will see what is the attributes means what are the columns present in our data set. So first is show ID means what is the unique ID for every movie, then type which is basically identifier means it tells whether it is a movie show, the TV show, then the title of the movie. Then director means director of the movie, then cast means the actors, then country in which it is produced and date added on the Netflix. Then release year means the actual release year, then rating of the show, then duration means total timing, then listed in means which is what is a genre of these. Then there is a small summary description of the TV show, the movie show. We will now see the information using the info function. So here you can see that there are 12 columns and there are total 7787 entries, and these are all the non-null values, and these are all the data types of this column. We will check if there is any duplicate value or not. So there are no duplicate values. We check using duplicated function and then used sum function to do the sum of all. So there are no duplicate functions. Now we will see what are the missing values or the null values. So using the isNA function and then summing of all. So here we can see that the maximum number of null values are in the director column and in the cast column, then country and a date added, and the rating has a least number of columns. So we will now visualize it using the heat map. So we can see that director column has maximum number of null values and the rating has the least number of null values. Now we will see what are the columns. So using the columns, these are all the name of the column. There is show ID, type, title, director. Now we'll statistical summary using the describe function. Now we will count the unique values using. So till now, what we have seen is that after analyzing the data set, we will focus toward type, title, director, cast, country, rating, listed, and description, all these columns. And because these columns carry a lot of information, so we will build our model on these mentioned features and where those features are used to create one cluster column to implement k-means hierarchy clustering, and then we will build content-based recommendation system. So now we will do is the EDA. So for doing the EDA, our first chart is what are we doing is we are checking how many count of the TV shows and the movie shows. So using the bar chart and the pie chart. So in pie chart, we can clearly see the percentage distribution of the movies is 69%, and for a TV show is 30%. And the count of movies is 5,377, and the TV show is 2410. Now we will see for the title column. So here we have created the word cloud in which we can see that words like Christmas, love, word, man, story are very common word which appear most of the time in the movie title column. Then we will check the director column. So what we are doing is we will check the top 10 director who directed the TV shows and the top 10 director who directed the movies. So these are the top directors. So Elster Fortiger directed highest shows in detail list, which is 3, and Rahul Campus and John have directed 18 movies higher than anyone in this data set. Now we move to the cast column. So here we are seeing who are the top 10 TV shows actor and top 10 movie actors. So we can clearly see that Anupam Kher and Shah Rukh Khan, Om Puri play the highest number of roles in the movies. Here you can see, and the Takirao, Yuki, and these play the highest role in the TV shows. Here we can see. Now let's move to the country column. Here we are seeing the top 10 country with the highest number of movies and the shows. So in our observation, we have found out that the highest number of movies and TV shows are based out of the US, then India, and after that UK. Now we move to the release year column. Here we are checking the data distribution by the released year and the movies or the shows released in the top 15 years, last 15 years basically. So we have observed that Netflix has greater number of new movies and TV shows than the old ones, and the highest number of movies and shows released in Netflix in between 2015 and 2020, and the highest number of count belong from 2018 year. Now we will check the rating column. So here we are seeing top 10 rating given for the movie and the shows. So most of the movies and the TV shows have highest rating of mature audience, then followed by the younger audience, and the highest number of rating given for the movies as compared to the TV shows. It is pretty obvious because of the highest number of category belong from movie class, as we can see earlier in the type column. Then we'll move to the genres. So here we are seeing what are the top genres present in the Netflix. So the highest number of genre belong from the international movies, then dramas, and then comedies. And the least number of genres belong to the classic and cult and TV thriller and stand-up and talk show. Now the description. So in this we have created the word cloud. So most of the common words present in the description cover on family, find, love, new, world, and friend. Now we will do the data cleaning. So as we have earlier checked that there are no duplicated columns. So we will handle the missing values now. So we have earlier seen that the missing values in the director, cast, and country attributes can be replaced with the empty string, and the small amount of null value present percentage present in rating and dated added column. So if we drop these values, it will not affect that much when we will build the model. So we will simply drop these in the rating and data added column. So here we are handling the missing values and doing the imputation. So we are filling using the fill NA function, we are doing it. And now we are checking that is there any missing values or not. So you can see that there are no missing values. Now we will handle the outlier. Since we can see that almost all of our data present in textual format except release here. So the data we need to cluster are presented in textual format. So there is need now to perform a handling outlier. Now we will do the textual data processing. So what we are doing is first, we will select the attributes based on which we want to cluster the shows. Then we will remove all the stop words and punctuation marks and convert all the text data to lowercase, then stemming to generate a meaningful word out of the corpus of words. Then we will stemming to generate a meaningful word out of the corpus of, and we will tokenize of the corpus and onward iteration. Then we will do dimensionality reduction. Then we will use different algorithms to cluster the movies, and then we will update clusters. Then we will visualize the contents of each cluster using word cloud. So first, what we are doing is we will cluster the movies or the shows on Netflix based on the following attributes. So these are the attributes: director, cast, country, rating, genre, and description. So here you can see that we have created the new column, that is tags, and we have added all these values in this. So we have created a single column, that is tags. Now we will remove the stop words and lower casing. So removing stop words and lower casing are the common pre-processing steps in natural language processing tasks. So stop words are used in the language that do not are commonly used in language but do not convey much meaning of their own, such as a, and, the, is. So these words can add noise and sometimes affect the performance of NLP model. So we will remove them. Then we will lowercase the word. So lowercasing means is to convert into the lowercase. It is a common task in the NLP tasks. So we will do it uh, using the NLP. What we'll do is we will first download the stop words list from the NLTK package using the download function. So here are all these the stop words. Then we have successfully removed all these stop words. Then and here we have also converted into the lowercase. Here you can see. Now we will remove the punctuation. So removing punctuations is a common pre-processing step in natural processing tasks. So punctuation marks like period, comma, exclamation marks can add noise and sometimes treated as separate tokens which affect the performance. So we will remove them. Now stemming. So stemming means uh, it is the process of reducing the word to its base or root form. This is common processing step in natural language processing task, as it allows you to treat different inflected forms of word as the same word, which can be useful for tasks like information retrieval or text classification. So for example, like words like run, runs, ran, running, all are different inflected form of the same word run. Now we have successfully done with the stemming the corpus. Now we will do the text vectorization. So it is the process of representing words as numerical vectors. It is a most important NLP task because most machine learning models can expect numerical input and cannot work with raw data directly. So here we have done the text vectorization. Now we will do the dimensionality reduction. So for this, we can use the PCA, that is principal component analysis, to reduce the dimensionality. So what is dimensionality reduction? It is a process of reducing the number of features or dimensions in dataset while preserving as much as information as possible. And it is a common step in machine learning and data analysis, as high dimensional dataset can be difficult to work with and sometimes suffer from the curse of dimensionality. So we have using the PCA, we have reduced the dimensionality. Now we will see the variance and we find that the 100% of the variance is explained by about 7,500 components, and at almost 80% of variance is explained just by 3,000 components. So to simplify the models and reduce the dimensionality, we can take up 3,000 components and we'll still able to capture more than 80% of the variance. Now we will do the cluster implementation. So first we will do is that the k-means clustering. So what is k-means clustering? It is unsupervised machine learning algorithm that is used to divide a data set into specified number of clusters. It is called unsupervised because the algorithm does not use any labeled examples to learn about the data. Instead, it relies on the inherent structure. So how it works is that first the k-means algorithm works by first selecting the k initial centroid or central cluster centers at random from the data. Then it assigns each sample in the data set to the nearest centroid based on the distance metric like Euclidean distance. Then the algorithm then updates the centroids to the mean of the samples in each cluster. Then iteratively repeats that process of reassigning the samples to the nearest centroids and then updating the centroids until convergence. So here we are doing is that visualizing the elbow curve and slot score to decide on the optimal number of clusters for k-means cluster algorithm. So here you can see that the some of the squared distances between each point and the centroid in the cluster decreases with the increase in the number of cluster. Now, using the sellout score method, we have found out the optimal value of k. So here you can see that we have obtained the two clusters. Now building the two clusters using the k-means clustering algorithm. So now we will see the number of movies and the TV shows in each cluster using the k-means clustering. So we have successfully built the two clusters. Here you can see that these are the two clusters. Now we will build the word cloud for different clusters and the k-means clustering. So for the description column, this is the word cloud. And for the cast column, these are the two word cloud. Then for a director, these are two word cloud. Then for genre, these are two. Then for the country column, these are the two. And then title. Now we will do the hierarchical clustering. So building clusters using a hierarchical or agglomerative clustering algorithm. So what it is the method of clustering that is used to build a hierarchy of clusters. It is a bottom-up approach where each sample is initially treated as a sample cluster and clusters are merged together as they are deemed similar. So how it works is the algorithm starts by calculating the distance between all pairs of samples and storing them in distance matrix, then select the two closest clusters and then merges them into the single cluster, and our process is repeated until all the samples are in the same cluster. So the resulting clusters form like a tree structure which is called as a dendrogram, which shows the relationship between the clusters at each level of hierarchy. So we will visualize a dendrogram to decide on the optimal number of clusters. So here we have created a dendrogram. Now we see the number of the movies and TV shows in each cluster in hierarchical clustering. So we have successfully built the 7 clusters using the agglomerative or hierarchical clustering algorithm. Now we will build the word clouds. So for the each column, we have built these word clouds. Now, what we are doing is the content-based recommendation system. So it is, I used to recommend the items to user by the similarity of items. So this recommendation system recommends products or item based on the description or features. It identifies the similarity between the products based on the description. So if we can build a simple content-based recommendation system based on the similarity of the movies. So if a person has watched a show, then the recommendation system must be able to recommend a list of similar TV shows that he or she likes. So to get the similarity of the scores of the show, we can use the cosine similarity. So the similarity between the two vectors is calculated by the dot product of the two vectors and then dividing it by the magnitude value. So we can simply say that cosine similarity of score for the two vectors increases as the angle between them decreases. So we have created, we have this data frame. Here we can see that there are total 7,770 rows, and it shows the last index is 7786 because of the dropping of the sum of while treating the null value. So in order to build content-based recommender system, we find out the similarity scores on the basis of the specific index with respect to that specific text column. And if we can't reset the index, there is high chance that we calculate the cosine similarity to another one index. Instead of that, we provide index. So in order to avoid this problem and address index property while building, we will simply reset the index. So we have successfully reset the index. Now we will build the content-based recommendation system. So for this, we have created the function to list the top 10 recommended movies based on the cosine similarity. So it has suppose if you have liked Naruto, then it will show that you can also enjoy these movies. And suppose if you liked Our Planet, then it will show these. Then or suppose if you have liked the Furhera Fairy, then it will show these type of movies. So what conclusion we have achieved is that so in this project, we worked on the text clustering algorithm. We have to specify the we have to classify or group into the clusters, and the data set is of 7,787 records and 11 attributes. First, we dealt with the missing values, then performed the EDA. Then we formed the cluster based on the attributes such as director, caste, country, genre, rating, and description. Then we did the vectorization where we created about 10,000 attributes. Then we did principal component analysis to handle the cost of dimensionality. Then 3,000 components were able to capture more than the 80% of the variance, and hence the number of components were restricted to 3,000. So we first built clusters using k-means clustering algorithm. Then optimal numbers cluster came out to be 5. And then after that, we did the hierarchical clustering, and the clusters were 7. And we visualized it using the dendrogram. And then finally, we created the content-based recommended system, which recommends 10 recommendation to the user based on the type of the show which they liked. Thank you so much.